My name's Miles, and I'm in grade 9 STEM. This year, my capstone was designing and making downhill longboards. My goals for this project were to learn how to use Fusion 360, learn new fabrication skills with new unfamiliar materials, and to use prototyping to create a functional design custom made for me. The first steps of this project were in Fusion 360, where I designed a mold that would give my boards their progressive concave, tail, and rocker. My final design for the mold was based off of boards I had already ridden, but had changes made where I wanted them. Once I was happy with my design, I got it cut out of foam on a CNC machine. The CNC ensures that everything is symmetrical, but making it out of foam allows me to make changes with a rasp if needed. I glued the two halves of the mold together on a single piece of MDF and covered the whole thing in tuck tape to ensure no glue got stuck to it. For my first board, I used 7 plies of 1/16 inch thick maple veneer, 5 long grain, and 2 cross grain. Each ply is glued together, stacked on top of each other, and placed on top of the mold inside the vacuum bag. The vacuum bag then sucks down on the wood with 25 pounds per square inch of pressure until the wood is completely conformed to the shape of the mold. At that point, the vacuum stops sucking and maintains a pressure of 25 psi. After 24 hours, the board is ready to be shaped. I drew a template and transferred it over a center line to get my shape. I roughly cut it out on the bandsaw and did the shaping with a disc sander and palm sander. Then I drilled the holes on the drill press and cut the wheel wells using the jig I made on the spindle sander. The main issue with this board is that the 7-ply maple layup wasn't stiff enough, and it didn't have quite enough concave. For the next board, I removed the tape from the mold and carefully shaved away the edges, adding more concave. This time, to make the board stiffer, I added 2 plies of fiberglass, one to the top and one to the bottom of the blank wood board. Although it was better than the first one, this board still had its issues. Adding 2 plies of fiberglass to the 7-ply maple layup made the board both too stiff and too heavy. Too stiff a board leads to a very bumpy and uncomfortable ride. The third and final board was an accumulation of everything I had learned with the first 2. Since I was making this board at home, I didn't have access to tools in the wood shop. This meant I couldn't sand in my wheel wells after the board was done on the spindle sander. Instead, I shaved away the edges of the wood before adding the bottom layer of fiberglass. This kept the board more waterproof and maintained wheel clearance. This board I made with 2 plies of fiberglass and 6 plies of maple. The 2 plies of fiberglass add torsional stiffness, while the 6 plies of maple add just the right amount of flex. I think the most important thing I learned through this project was the importance of prototyping. Going into it, I thought I'd be able to make 3 perfect boards, but that definitely wasn't the case. Each board had its flaws, and even the last one that was a combination of everything I had learned wasn't perfect. My next steps with this project would be to keep moving forward and making new boards. I'd like to try new construction methods and make new molds. Hopefully, if we can get the CNC running in the wood shop, I'll also learn how to generate tool paths and use the CNC myself.